Hello and welcome to DataCast Solutions, Statistics and Data Mining 101 using KNIME. In this chapter we're going to talk about character string manipulations. Of course, most often character strings usually represent categorical variables, which take a known set of values, and as a good rule of practice it's always worth checking to make sure that those values are legal values. That should be part of your exploratory analysis and data corrections. If it's not a character string representing a categorical value, then the real question would be, why is it in your data set in the first place then? Why was it not factored out early on when we talked about removing things like addresses and things that did not provide meaningful input into your model? Character strings do sometimes have an ordering. Of course, the natural order is alphabetical. Alabama becomes before Alaska. And while that's helpful for librarians, it's less useful for data miners. The thing is, when there is sensible ordering, it makes sense to replace those categorical values with numbers. Let me give you a clear, easy example is military ranks. I can say that it should go from lieutenant to captain to major to colonel to general. So even though those aren't the alphabetical ordering, there is an ordering to it in the hierarchy of the military rank. And it would make sense to me in that case to replace the rank name with a rank number. Remember, less is more. Just as the reminder from our binning discussion, data mining algorithms are always going to perform better when there are fewer categories rather than more. So certainly whenever possible, I want to do that cardinality reduction. One easy way to reduce the number of categories is to use attributes of the codes rather than the codes themselves. Let me give you, for example, in our lifetime, how many different versions of mobile phones have been created, and all the different permutations of each of those mobile phones with all of the various features. It would be impractical to try and use all the categories of every mobile phone. What you might instead do is build separate fields, separate values to say, let's talk about handset weight, original release date, major features type categories, so that instead of hundreds of thousands of categories, you wind up with just a few, 3 or 4 or 10 new fields with 3 or 4 values in each one of those fields. Now you're going to see eventually that neural networks and k-means clustering are two examples of algorithms that want their inputs to be numeric intervals, and that's a real problem. So your very naive approach might be to say, well, I'll just assign numbers to them. The problem is numbers have meaning, especially in terms of their ordering, and you can very easily wind up with spurious ordering can hide information in the data. A much better approach is to create a set of flags called an indicator variable and make them 1, 0 for yes, no. For example, you could take marital status and have a 1, 0, are you single? A 1, 0, are you married? A 1, 0, are you separated? And so on. Each one of those individual values will then be read into the neural network and be processed much more efficiently. KNIME thankfully provides a very specific node to do just exactly that. All right, let's take a look at a couple of the different string management capabilities. I put together a handful of examples to show some of the things that we can do with this. So for a start, when I look at my output and my data, I can see that I've got what do we got? 5 here records, 6 records here that have very excessive contributions. These are our major people. And so I've decided I'm going to exclude them from analysis because maybe we manage these people differently. We don't, do automated emails and things like that to these kind of donors. So we treat them separately. So I'm going to remove them out of my analysis. So all I'm going to use in this case is the row filter. And I've taken the total amount given, and I did a range check to say the lower bound will be 30,000. and exclude any row that matches this attribute. So I could do it based on a pattern or missing values, but in this case I just want to say everybody 30,000 or more and exclude the rows that match that. So that's one way to just filter out some rows. Another item you'll notice within here is the way the file reader worked is it read this column called champion as a string. So since you know that most of these routines are going to prefer numbers, I can use the string to number node, and I'm just going to tell it I want to take champion and I want to convert that to an integer. You can choose from different types, so I'm going to make that an integer, and champion now becomes a numeric value instead. Another thing I can do is category to number. So what I'm going to do is I'm going to take this column called skill level, and I'm going to append a new column. I'm not going to replace it. I'm going to put a suffix of to number, and I'm going to start with 0 and increment by 1. So I'm going to translate skill level into a numeric set of values. Let's look at what we have for skill level. Okay. Right now I have beginner, expert, advanced. So if I look at the possible values for skill level, I've got beginner, advanced, expert, and unknown. So again, alphabetically, they would actually, they would show up, if I were to sort it that way, by advanced, beginner, expert, unknown. In this case, I'm actually going to do it such that I'm just going to convert them directly to numbers. So by converting the category to number the way I did, if I move that over, you'll see beginner got 0, advanced got 1, okay, expert got 2, and unknown would have gotten 3. Now, string replacer node, also useful if you need to make some simple changes, like I'm going to take race and I need to change Caucasian to Caucasian non-Latino. You can use wildcard and regex expressions on this as well. You can create a new column instead of altering this one if you like. But what I get out of here now is it's changed race from Caucasian to Caucasian non-Latino. Now, the string manipulation node, I used to use a great deal, but honestly I use column expressions much more frequently once they came out with that. With string manipulation, there are all kinds of functions that you can perform on strings. Finding values, capitalizing and knit caps, replacing values, padding left or right, substring stripping. In my case, and what I like here is you can embed functions within functions within functions. So in my case, the innermost function, I replace the column gender, I replace the value male with M. And then this value right here becomes the field, the first parameter to this replace, which is then going to replace female with F, and then the outer one will replace unknown with U. So when I run something like that, I've now replaced gender. And I've now got M, F, U as values. All right, let's scroll down a little bit now. A nominal value filter. This one, what it's going to do is you can choose a column, like in my case, marital status. What I'm trying to identify, all of the possible values, unknown, single, divorced, refused to answer, widowed. I want to create supercategories. I want to say that basically these are people living alone. These are people who, it's a couple. So basically I want to say single or couple. So what I can do here, the output of this, the records that were included were the married, well, the domestic partners and the married, and the separated. They all came out, and then I'm going to give them a value of couple. Now, to those that didn't, I'm going to turn around and give them a value of person. Okay? And giving the same column marital status aggregate is what I was applying that to be. So now each of these, if I look at this output, all of these people are referred to as a couple. All of these people are going to be referred to as a single person, and then I concatenate them back together again as one data set. So these are just a couple of the ways that you can use to do string manipulation to handle some of the binning and categorization changes that you have to make. All right, I'd like to show you one more thing, and that's when we want to put a specific order by category. When we looked at the category by number, we chose the column skill level, and it just assigned a numeric number in order. So the first value it found got the number 0, the next value it found got the number 1, the next value the number 2, and so on. There was no force upon it. Well, when we talked about examples like military rank, where I need to put them in a specific order of lieutenant, captain, major, lieutenant colonel, colonel, general. So to accomplish something like that, I'll use a column expression. And what I'll do within this node, column expressions allow you to specify in JavaScript, you can supply structured if then else. So I can say, so if skill level is beginner, set it to 1. If it's advanced, set it to 2. If it's expert, set it to 3. Else set it to 0, which would be our unknown. And now I can have, now that order means something. The higher the skill level, the more advanced you are. So this column that I'm generating, ordered skill level of type numeric integer, will now represent that and could be used in things like neural networks. And the output of that ordered skill level now, 1 is beginner, 2 is advanced, 3 is expert, and so on. And if I sort that, all the unknowns got the 0s. All right. As we talked about, the idea of replacing values with numbers can actually throw some of the modules off, like a neural network, because there is an implied order. 1 is higher than 2, and so on. And we oftentimes just want a binary value of like yes or no. And so instead of changing something like marital status or gender, making gender 1 is male and 2 is female, implying some order to it, instead we're going to use the one-to-many node to generate individual columns for each value to represent a yes-no flag. And that will work much better in a neural network or a k-means. So let's go ahead and sample the one-to-many in the KNIME workflow. In my node repository, I can search for and find the one-to-many node, and I'll just drag that up here onto the screen, and I'll connect my output file to it. And I'm going to take the column marital status. So I'm going to remove everything else and just take the one column. I'm going to take gender. Keep this nice and easy. And when I execute it and look at my data now it has added 3 new columns. Are you a male? 1, 0. Are you a female? 1, 0. And are you unknown? Each of these are mutually exclusive, of course. But this will work great in a neural network that just says each of these are basically attributes of an individual row now instead of a category of attributes. That completes this chapter of the class. Feel free to move on to the next chapter.